The next talk will be jointly given by Rohitashwa Sarkar and Manosij Ghosh Dastidar. Rohitashwa Sarkar is an ex-MPhil student at Center for Studies in Social Sciences. He did his BA and MA from Jadavpur University Department of English. He is going to do his PhD on the mathematical differences in the work of the philosophers Badiou and Deleuze, both of whom have been instrumental in cultivating his interest in the history of mathematics. He is especially interested in set theory, calculus, and the broader history of infinity in the history of mathematics. Also, he is keenly interested in the intersections between mathematics and philosophy. The other speaker is Manosij Ghosh Dastidar. He did his integrated bachelor's and master's in mathematics in Pondicherry University. His research interest is primarily number theory with a focus on integer partitions and modular forms, which is the topic of his doctoral proposal. Apart from that, he is interested in mathematical philosophy and foundations of mathematics. I kindly invite them to give this speech.
So the topic of our presentation is a long-standing debate regarding the history of how infinity came to be thought of as actual as opposed to potential. This is a long-standing debate in the history of mathematics and mathematical philosophy, which goes back all the way to Aristotle. And we've chosen three pivotal figures in the history of Western thought to take us through important moments in this history. And these pivotal moments are represented by three figures who are Aristotle, Leibniz, and Cantor. So I'll be covering the contributions of Aristotle and Leibniz, and Manosij, my peer, will be covering Cantor and also contributions by Indian mathematicians. So I'll start without further ado. So Aristotle in book 3 of the Physics has a famous refutation of Zeno, the Greek philosopher Zeno's notion of infinity. I think we're all aware to some degree of Zeno's paradoxes on infinity and the nature of his infinity. So Aristotle suggests that an infinity of the kind that Zeno is talking about, where you can cover half the distance of an entire thing and then cover another half and then cover another half, and this continues ad infinitum. So this will never complete. Like we will never, although we are calling this infinity, this entire entity is never going to be a completed whole. It will always be a process that is going on and on. So if we try to cut off a section of it and say that this is sufficiently large enough for us to designate this as infinity, but that section will always nonetheless be finite, because, and so at the actual level, and so for Aristotle, for a thing to be actual, either an object of thought or a physical object, for it to be actual, it has to be totalizable. It has to be a whole, a complete entity. It cannot be a process that will never complete itself. And so because the completion is always something that will always happen in the future, so it is always potentially complete, but never actually ever completely there. So infinity is by nature potential. Actual infinity is paradoxical in the Aristotelian paradigm. And this is an argument that broadly influences a lot of post-Greek medieval thought, theological thought about the infinity. And I'll touch briefly upon some of the considerations in medieval theological thought before I move on to Leibniz. Like the medieval period, when most theologians broadly retained this understanding of infinity as potential, as never actual. However, there's a slight modification that they are doing. So infinity broadly in medieval terms is understood in three separate domains. Like there is infinity of nature, that is to say infinity concerning matter, which concerns questions of whether or not matter is infinitely divisible, etc., etc. And then there is a mathematical infinity, which has been debated and discussed since the Greeks regarding whether a line segment extends onto infinity or not, etc., etc., whether a point is a continuum of infinite points, whether a line is a continuum of infinite points and stuff like that. But then there is also a theological infinity which transcends all of this, which is the infinity of God. And so here, it is with the conceptualization of God within a Christian theological paradigm that slight aberration happens from the traditional Aristotelian framework, because one cannot possibly say that God's infinity is potential, because if we remember, for a thing to be actual in the Aristotelian paradigm, it has to be it has to be a whole, it has to be complete, it has to be it has to be complete. Completion is the main point. So it's not, one cannot really say that God is incomplete as an entity. God is both complete and infinite. So we hear in the notion of God within a Christian theological paradigm, we find a notion of an infinity that is both infinite but complete. And so this is a slight aberration from that Aristotelian understanding of infinity as necessarily potential, but nonetheless at the level of um, natural or mathematical objects, or just any object of coherent thought uh, apart from God, uh, the understanding of infinity broadly remains as the infinity is understood as potential and not as an actual object. So there's a important linguistic concept that I need to introduce here for me to explain the next part I'm going to go into. There in medieval theology, there is so there are two terms. The terms are the categorimatic and the syncategorimatic, and these are two linguistic terms which are used to describe components of a sentence. Uh, so if we have a sentence of the form A is B, like say every base is an alkali. Uh, so there we have a subject and a predicate, like base and alkali. So the subject and the predicate give content to the sentence, but the term every is not giving any determinate content to the sentence, but the term every is designating that whatever is being said by the subject and the predicate is valid for everything. So it is the term every is a universal affirmative, essentially. Similarly, we can have other statements like no pagan is a Christian. So like if the term no there is designating a universal negative, like it is invalid for all cases. So terms like things like universal affirmatives and universal negatives, these are called logical constants. Uh, these things are essentially what are clubbed under the term syncategorimatic. These terms like every and no or some, these on their own, without attachment to a subject and a predicate, they do not have any definite sense. They have an indefinite sense. Whereas a subject and a predicate, which fall under the categorimatic terms, these have a definite sense on their own. Like I said in the examples, like a base and an alkali, they have the words base and alkali mean something on their own without necessarily being contextualized in that sentence. But the words every and no and some, these things need to be attached to the rest of the sentence along with the subject and the predicate for it to make some sense. So the point is that the syncategoric terms, grammatic terms, which include the terms every, some, and no, these are indefinite on their own, whereas the categorimatic terms, which are the subject and predicate terms, are definite on their own. And so the syncategorimatic terms, which are indefinite on their own, because of their nature, their indefiniteness itself, this is used analogically to describe the nature of infinity. That was the point of that long digression. So the infinity within medieval paradigm is thought to be syncategorimatic because it is by nature indefinite, it is incomplete, it is always a process, it is never a completed whole, never definite and fixable on its own. And so this understanding of infinity as syncategorimatic more or less maintains the understanding of infinity as potential. So Leibniz, if we just move away from the medieval paradigm and come into Leibniz's breakthrough, Leibniz's main contribution here is to show what he does is remarkable because it is inconceivable within the medieval paradigm. He says that it is precisely the syncategorimatic infinity which is actual. It is not potential. What does this mean? This means essentially that the actual need not necessarily be complete anymore. The actual can be incomplete. It can be a process. It does not need to be a unitary whole. And this is actually quite apparent if we look at Leibniz's philosophy of nature, for example, like he has an understanding of nature. Every particle of nature is infinitely divisible. It just keeps dividing uh, on and on and on without ever breaking off into indivisible, separable atoms. He's completely against all forms of atomism. So the parts that are divided do not separate. They're all part of a continuum, but this continuum is constantly internally self-dividing. And uh, so this is the level of actuality. Actuality is not something where you can grasp an object and say that this complete whole object is actual. Actuality is always breaking down, always in a process, always uh, but you can never grasp its wholeness. And so it is precisely by intervening into the nature of actuality, precisely by reconstructing the notion of actuality, that he's able to make a rupture in the Aristotelian and medieval paradigm of thinking about infinity. Uh, this is broadly the topics that fall under Aristotle and Leibniz that we have covered. My Manosij Rohitashwa will now talk about the contributions of Cantor and Indian mathematicians.
So I'll start from Cantor and move on to the different aspects of infinity by Indian mathematicians, as well as uh, circle back to how all of this relates to these figures that we talked about. George Cantor gives us a truly mathematical notion of the actuality, defined in terms of cardinality. What makes Aleph naught and Aleph 1 actual is that they can, in a sense, be measured as cardinality. By making cardinality the ground for actuality, he creates what is perhaps the first properly mathematical and a non-philosophical definition of actuality. I will talk about what follows is a short historical demonstration of how this idea first developed in Hume and went from Galileo into Leibniz and into Cantor. In a treatise of human nature, Hume writes that I have already observed that geometry or the art by which we can fix the proportions of figures, though it much excels both in universality and exactness, the loose judgments of the senses and imagination yet never attains a perfect precision and exactness. Its first principles are still drawn from the general appearance of objects, and the appearance can never afford us any security when we examine the prodigious minuteness of which nature is susceptible. Our ideas seem to give a perfect assurance that no two right lines can have a common segment. But if we consider these ideas, we shall find that they always suppose a sensible inclination of the two lines, that where the angle they form is extremely small, we have no standard of a straight line so precise as to assure us of the truth of this proposition. It is the same case with most of the primary decisions of mathematics. There remains therefore algebra and arithmetic as the only sciences in which we can carry on a chain of reasoning to any degree of intricacy and yet preserve a perfect exactness and certainty. We are possessed of a precise standard by which we can judge of the equality and the proportion of numbers, and according as they correspond to or not to that standard, we determine their relations without any possibility of error. When two numbers are so combined as that the one has always a unit answering to every unit of the other, we pronounce them equal. And it is for want of such a standard of equality in extension that geometry can scarce be esteemed a perfect and infallible science. The word numbers here refers to a collection, since the word set was not in usage at that time. It is crucial to make a note here of the kind of language that has been used, a unit answering to every unit of the other. This language foreshadows the mathematical concept of a one-to-one correspondence or bijection between sets. The interesting part is that Hume chooses to pronounce them as equal. If Leibniz had made similar deliberations in his mind, it would put him in an uneasy situation because it would violate his seminal principle called the indiscernity of identicals. Leibniz put forward this ontological principle along with his identity of indiscernibles, which became so widely used and agreed upon that it later became to be known as Leibniz's law. Simply put, it states that if an entity A is identical to B, then A and B have the same properties. Leibniz could see quite easily that one could put the set of natural numbers and the set of even numbers in a one-to-one correspondence, like 1 goes to 2, 2 goes to 4, 3 goes to 6, 4 goes to 8, and so on. But to say that the set of natural numbers and the seemingly smaller set of even numbers had exactly the same properties was an idea Leibniz was not able to accept. This is a plausible reason why, in spite of his conviction of the existence of the actual infinite, he would not go on to accept the position Cantor would later take. So, in spite of his respect for Leibniz's metaphysics, Cantor, unlike him, did not feel the need to be restricted by them. His idea of infinity was remarkably different from what anybody could conceive of at that time, and the cultural resistance to his set theory was inglorious and oppressive. The truly radical idea in his theory was the rejection of Euclid's fifth axiom: the whole is greater than the part. It stems from the idea that since comparison was only meaningful while we were conceiving of finite sets of objects, it is at best a contingent truth and can easily not be valid for infinite sets. Instead of finding ways to subvert Galileo's paradox, Cantor embraces the spirit of the paradox. For example, Galileo's famous paradox, he put it in this way with an example that there is a one-to-one correspondence with each number and its square. 1 goes to 1, 2 goes to 4, 3 goes to 9, and so on, which made Galileo convinced that since there is for every square a positive square root, so it would seem that one set could not be greater than the other. He concluded that the words less, greater, and equal loses significance in a discussion of infinite sets. Instead of being uneasy about the nature of this problem, Cantor chooses to make this the bedrock of his theory. He follows Dedekind's definition that an infinite set is precisely one which has a one-to-one correspondence with a proper subset. When it came to infinite sets, he had two laws. The first was that if there existed a bijection, a one-to-one correspondence between them, they were equivalent. He ascribed to them the same cardinality. The second was the set of integers had an infinite number of elements whose cardinality he denoted by aleph naught. The cardinality of power sets of every infinite set was of a greater cardinality than the corresponding sets which initiated the study of cardinal numbers and the transinfinite. From a philosophical standpoint, all of Cantor's formalism, including things that have been done in ZFC and the Schroeder-Bernstein theorem, which was actually proved by Cantor, this is significant because it shows us that even in Cantor's formalism of actual infinity, the construction is not absolute. And with his formalism, we can compare and classify different kinds of infinite sets. But even Cantor realizes that the iterations of subsequent alephs and their formulation of being the power set of one another creates a different paradigm of infinity, which is not captured in the paradigm he creates. In his own words, in a letter which he wrote to Richard Dedekind, he says, "I have never proceeded from any genus supremum of the actual infinite. Quite on the contrary, I have rigorously proved that there is absolutely no genus supremum of the actual infinite. What surpasses all that is finite and transfinite is no genus. It is the single, completely individual unity in which everything is included, which includes the absolute, incomprehensible to human understanding. This is the actus purissimus, which by many is called God." So at this point of time, we take a break from these key points in history and turn to the Indian context of what we are trying to discuss here. we see that interesting developments have been taking place for centuries, which require a lot of close scrutiny. For example, as early as in the 6th century BC, Jain mathematicians had delineated the infinity into 5 categories: infinity in one direction, infinity in 2 directions, the infinite in area, and the infinite everywhere, and perpetually infinite. While from the categorization, it is clear that their understanding of infinity stemmed from a spatio-temporal paradigm, we must also recognize the fact that they were also willing to transcend that very idea to their conception of what they call infinity everywhere. This conception being quite close to the idea of an actual infinity, which we have discussed previously. Now we have seen how Leibniz's rejection of the Aristotelian orthodoxy regarding infinity led him to cement his theory of modern calculus. At this juncture, I want to stop and talk about a very pertinent issue. If you stop at this juncture to analyze the work of Madhava, the founder of the Kerala School of Astronomy and Mathematics, he had formulated the infinite series representation of trigonometric functions, pi, and so on, which would only appear in Western mathematics a couple of centuries later, using formal, and he did all of that without using formal methods in calculus like Taylor's expansion and so on, which leads a branch of historians to point out claims of Eurocentrism in the outlook towards modern mathematics, and make the claim that early formulations of calculus were thus made in India far before the West. Instead of choosing to invest in that line of questioning, we want to take this even further and see the significance of what Madhava had actually achieved. His result shows us that it's possible to conceive of basic calculus within an Aristotelian framework, which was never present in Western mathematics. In fact, Madhava and his successors would go on to find infinite series expansions for pi as well, based on their knowledge and treatment of infinite continued fractions. In this juncture, the question of the influence of infinite continued fractions in the development of mathematical ideas in the far south is a very interesting question that should be taken up in greater detail, as we can see that this influence persists throughout the centuries. And it would even influence Ramanujan, who made remarkable contributions in this field of inquiry. And as we know, that he completely challenged our preconceived notions of infinity. With that, I'll try to conclude for now. Thank you. If there's anything.
Yeah, I would cordially thank both the speakers. So now we are open for question and answer.
I have a very quick question. What did you mean by saying placing Madhava's work in Aristotelian context?
Again, so the Western idea of calculus, which has come up precisely from following a philosophy of Leibniz, that is entrenched in Leibniz's conception of infinity as an actual infinity, which is a departure from the Aristotelian paradigm. As Rohitashwa mentioned, he looks at infinity as an actual infinity, as a syncatagormatic actual infinity. He departs from the Aristotelian framework, which is that infinity is always in its potentiality, like the successive iteration of 1, 2, 3, 4, 5, and the process goes on and on. So his infinity was potential. Madhava's work, which he had, the results that he got without using the Taylor's expansion and everything, he proved his work in his own paradigm, and his idea of infinity is actually the Aristotelian potential infinity. So what I am trying to posit here, that it is very interesting to see that even within an Aristotelian framework, it is possible to conceive of a basic idea of calculus.
If I may add a remark here, I think your thoughts have been very, very interesting, and it's very interesting to look at the trajectory of the concept of infinity. But for the Indian part, you will need, in my opinion, to do more work, because there are already some scattered hints in the Vedic literature, but coming as Dr. Deepak Barwani also remarks in the chat box to the Jains, they were certainly, trying to reach some concept of infinity and playing with infinitely large numbers very early on. And there's no doubt that this has influenced the later concepts of not only infinity, but also the zero. Brahmagupta is one who formally played with these concepts, formally. So I'm not competent to combine this with the philosophical concept of infinity in India, which has its own, its own realm. I'm not really competent. I'm not sure whether this has been done in depth. Perhaps you would have a lot of potential explorations there. But jumping to Madhava is not sufficient.
Sorry, my bad. The point I was trying to get to is the fact that the Western ideas of infinity have also been successfully explored in the Indian context by various different scholars, and very significantly, in fact, which was my which the fulcrum of my argument here was the fact that while many people wanted to talk about whether Madhava had actually discovered a basic form of calculus or not, I think it goes far beyond that, in the sense that in an Aristotelian framework, he actually has figured out a way to phrase calculus, which is very significant, because we only, in the modern mathematical sense, we only use calculus in the Leibnizian understanding of it, not in an Aristotelian framework. But Madhava's work shows that it is actually possible to conceive of it in an Aristotelian framework, which is very interesting to me.
Yes, indeed. But then you might have to trace the whole history of the exploration.
Yes, it's difficult to posit all of that within this time frame. I'm very sorry.
True. Other comments?
If I may to continue what you just said, there are two issues. First of all, in Aristotle, I don't want to use the blanket term Western, because it doesn't mean anything. I mean, Aristotle is something, Leibniz something else, and there have been attempts to say that everything comes from a single source, but this is political, this is not mathematical or philosophical. But the first point is that in his tradition, and this was a major conceptual block, there is a relation between theology and mathematics that's very strong in Aristotle, and that's the reason why the Catholic Church took over the Aristotelian framework. But in India, you don't see that. And there are other philosophical issues. For instance, to take an example that I've actually written a paper on recently, if you take the Linguistic episode, which is very famous, where Shiva appears as an infinite column of light that cannot be reached by Brahma or Vishnu, that tried to reach both of its ends. That there is clearly a reference not only to the difference between the potential and the actual, but also to the fact that there is a bidirectional infinite. And the literary mentions of this, or maybe about the same time as Brahmagupta. So here you would have something that may be relevant to what you're saying. But there are other dimensions in Madhava's work. I don't think that we don't even have we have what Yukti Bhattacharya says about him and stuff like that. But what seems to be going on in Madhava is that from a purely mathematical standpoint, what is going on is that when you have series that are additive, that is, that each correction comes as an additive and not as a result of a sequence. Because if you look at the way you rectify the circle by using polygons, then the formula from n sides to 2n sides involves a square root, and you need to get the whole result. You don't see the correction as an additive. Now, if you start realizing that there is something like the beginning of a series, then you see that the decimals stabilize. And therefore, it's easy. I mean, you don't need any metaphysics to do that. You need to have a sequence of computations that give you one decimal at a time. Then it's absolutely natural to say that, well, then it goes on forever because the corrections never become zero. And so this is something very simple and can be expressed merely in mathematical form. The point is that they didn't have the Aristotelian framework, and this is why I would agree with what Ramsovania said, that there is no clear indication, maybe there was, but that would have to be established, that they had been influenced by Aristotelian philosophy. And so they had something which was very simple. And maybe it's not a good idea to call it calculus. I mean, it's true that this was a main stepping stone for calculus, but calculus is the calculi are in Latin, they are small stones. These are pebbles with which you compute. And calculus is infinitesimal calculus because it's an algebra that in which the variables are replaced by the dx and the dy, which are infinitesimal. And you don't have that in India. That's fine. That's not the issue. But it is possible to see a line of thought that separates clearly the mathematical and the philosophical. Now, it is of course legitimate to try to see what this means philosophically, and I would suggest that the main point of Indian philosophy that's completely absent in Greek philosophy and only starts to be investigated since Kant and so forth is that the question is who is the subject? Who is talking about the infinite? When you say the actual, for whom, for what subject? And this is the reason why Cantor became mad because he wanted to say that he was a subject against God, and he wanted to say that he knew what God had to accept. But the Indian standpoint was something different, and this is what you see in the Ligod Baba episode. The main point in the particular text that I analyzed, which has to do with Tirunamala, what is going on is that there is a fight between Brahma and Vishnu, because Brahma doesn't accept that he comes from Vishnu. He believes that because he's creating something out of his mind, he is born out of nothing. And Vishnu tells him that he forgot his own birth, that he comes from Vishnu. And he himself considers that because he's the one who rules the world, also he's the only possible subject. And that's why there is a clash between the two. And the appearance of Siva, that is the appearance of the infinite, that is bidirectional in time, that is the sequence of generations that go from the remote past to the remote future, is something that gives a way out. That there is something else. That first you need to understand who if you as a subject talk about the actual infinite, who are you? And this is a question which is very familiar to Indian philosophy, and it is completely neglected because you have to remember that Aristotle was Alexander the Great's teacher. There is a clear relation between the Greek philosophy and the Hellenistic world, and Alexandrian imperialism, and later Roman imperialism. And therefore, the idea that they want to have a unique word, what they call the oikumene, the inhabited word in which everybody would think the same thing, that led to the suppression of the individual subject. And Indians, since the Upanishad, they haven't done that, which is a basic difference.
Right.
I would just like to make one remark that it's absolutely true that largely within the paradigm of Greek and Hellenistic philosophy, the question of who is the subject, the question of the subject that is perceiving the actual or the potential infinity, and therefore legitimizing what is actual and potential is absent. But I do think that there are instances in the entire history of Western philosophy where the question of subject does come up. The question of who is perceiving what kind of perception is happening, which allows us to designate something as actual or as potential or as any object of truth, etc., etc.
But that's the Linguistic Baba. The Linguistic Baba is that. If you look at the Linguistic Baba legend, is exactly about that problem.
Right.
Because Brahma and Vishnu, there is a column which is we know that it's the actual infinite from the text, but Brahma sees this column, Vishnu sees it. And they say, I want to know where the end of this column is. And you know the usual, everybody knows that Brahma takes the form of Hamsa and goes upwards. And there are various versions in the Puranas. They correspond to different philosophical ways of looking at it, which is interesting to study. But and then Vishnu goes downwards as a boar. And Vishnu realizes that he's never going to reach it. That is, he realizes that there is something that's going on that he's not going to reach. So there is here, at this point, there's a difference between the actual and the potential. What he can actually do, and so someone with superpowers, all the powers you may imagine, even someone with all the powers you may imagine, will not reach the actual infinite.
Yeah.
And then the other subject say, well, for instance, in the Siva Purana, there is an interesting way. He meets, so the whole thing would have to be explained. It's interesting. He meets a flower that is falling as he extends. So it's not a flower; it's a part of the Tarambu. It's a model. That's the part that's under the flower, and it was on Siva's neck, and it is coming down, and he apparently able to speak. So and it tells Brahma, well, you have reached. I've been falling for countless years. And you're never going to reach it. And then what he decides to say is that he decides, because he doesn't want to admit that he's not going to reach the actual infinite, and so he decides to say that he's going to lie. And this lie is to say that, well, I can conceive the infinite, because that's the real Brahma, that's what it means. He believes that I can conceive the infinite, therefore I have reached it. Reaching with the mind, he believes is the same thing as reaching actually. And so you see the two different reactions. One, Vishnu actually recognizes that there's a difference, and Brahma is trying to lie and suppress the difference. So it would be interesting. I mean, it's a whole thing. I've done only part of it. Each of the Puranas takes a different stance. And they take it in a different way, and each of these corresponds to a different way of tackling the problem. And the relation is that it is contemporaneous with Brahmagupta probably, but the two can be discussed separately. And as you know, in India, that's also a very interesting thing. There's this tradition of public dialogue that's, the people that give speeches and people who try to talk about it, but they don't try to define a doctrine that everybody would have to accept. And that's very good, because the freedom of thought is there. Because if there is a doctrine that everybody is supposed to accept, that it becomes really a religion in the very strict sense. And this is something that has been avoided. That's why people often say that there is no religion in the Western or Roman sense in India. Actually, it is not clear that there is a concept of religion in the Roman sense anywhere, even in Greek. If you look at what is called, there is a monograph by Rudart on the Greek religion. The notion of religion, there is no word in Greek that corresponds to the Greek word religion, that is something that's collective belief that has to be accepted by everybody. There's notion of devotion and things like that. There's sacred, but not the notion of religion. And it's very important that to keep these things separate, because a religion becomes some sort of a political party if you take it in this sense. And so it is a very good thing that in India you do not see people trying to convince everybody at the same time that something is absolutely true. This is
right. Thank you.
Perhaps we should now close this presentation. I think there was a lot of food for thought on both sides. If I may ask a tiny footnote, Professor Christian Sami, as I said, there are scattered references even in the Vedas on the concept of infinity. And Ligun Bhava has its roots in the Rig Veda, because Agni in the Rig Veda is without extremities. Without extremities. I can fetch the correct reference and the Sanskrit.
Yeah.
So I believe it derives from that. That's just a small footnote, by the way.
Yeah.
Unless there is some...
Baba is a column of fire, so this...
It is a column of fire, and Agni is without extremities. So I do feel it comes from